Okay, in the next lesson, we're going to be solving trigonometric equations. And actually, everything we've done this chapter has built up this topic of solving trig equations. A trigonometric equation, first off, can have several solutions, and we know that, and it's because of the repetitive nature of them. If we want to know where a graph is equal to something else, there might be several places where those two things are equal. So it might have several solutions, and it all depends on the interval that we're defining. To solve a trigonometric equation, you must first isolate the trig function. So we're getting the sine, the cosine, tangents all by themselves, and we do have to watch out for extraneous solutions with these. Let's go ahead and start solving them. It says solve each equation for the given interval. In questions 1 through 4, give the solution in degrees. For questions 5 and 6, we're going to do it in radians. So the first one says 6 sine theta minus 3 equals 0, and we want the answer between 0 and 360. And here's what we're going to do. And this is why knowing the period of sine, cosine, and tangent is so important. We're going to look for, first off, your first step is find all solutions in one period of that trig function. So in this one, sine, we were going to be looking for all the answers between 0 and 360 anyway, because 360 is that period. So step number 1, we're going to isolate the sine value. So we're going to move the minus 3 over just like we would if it was a linear equation. So we now have 6 sine of theta equals minus 3 turns into plus 3 as we move it over. We're then going to divide by 6, and it gives me the sine of theta is equal to positive 1/2. And notice that I said positive 1/2 because that's super important, because the next thing we've got to ask ourselves is, okay, where is sine positive? Because we might have multiple answers here. Now, I just want to remind you, we've actually solved some basic trig equations before by moving sine over by doing inverse sine. And we're doing the same thing now, except for we're actually discussing those trig equations actually had multiple solutions that we might not have found all of them the first time we went through and solved these. So first, next thing we're going to ask ourselves again, where is sine positive? And again, all students take calculus. So sine is positive here because everything is, and sine is positive here. So you will have an answer in this quadrant, and you're going to have an answer in this quadrant. And I just want to let you know that those two answers, how do I know what those two answers are? Well, they're just going to have the same reference angle. Because if the sine is equal to 1/2, well, we know that that theta value in the first quadrant, I know that the sine of 30 is 1/2 because that's one of my values that I memorized. And this angle here will also have a reference angle of 30. So if the reference angle is 30, and I know that this is 180, take 30 from that, and I know my other angle is 150 degrees, that's the two angles that have a sine of 1/2. Number 2, not quite so easy. Well, maybe it is. Let's take our plus 5 and move it over by subtracting 5. And I have negative 1 is equal to the cosine of theta. So actually it's pretty simple to get that one by itself. So we do the exact same thing. We ask ourselves, okay, where is cosine negative? So we're going to draw this. All students take calculus. So cosine is negative here because only sine is positive, and cosine is negative here. So we might have an answer in both our second and third quadrants, but I noticed something about that negative 1. If you go back and talk about your unit circle, and I'm going to go back to my unit circle here, where is sine equal to negative 1? Well, I know that cosine, I know that cosine is equal to negative 1 here. That's one of my quadrantal angles. So I said it was going to be in the second and third quadrant. It actually is. It's in between the two. So that's going to be the only place where I have a cosine value that's equal to negative 1. My only answer is going to be 180 degrees. That's going to be my value of theta. And notice they asked for the answer between 0 and 180, and it is inclusive, including 180. So therefore, that's going to be my only answer. Number 3. We're looking for, let's divide by negative 2. Mark that out. Divide by negative 2. The 2's will cancel. And I have the tan of theta is equal to negative root 3. And they're asking for the answers between 180 and 360. But here's the thing. Tangent. What I'm going to do first is I know that the period of tangent's actually 180 degrees. So I'm going to look for my first answer between 0 and 180, and then I'll use it to find all the answers from here to here. So since tangent is negative, again, I only have to worry about 0 to 180. So all students It's going to be negative here because everything's positive here. So I'm going to have a second quadrant answer where my sine, or my tangent, excuse me, is equal to negative root 3. Okay, here's how I do this. Next thing I do, I actually think about, well, where's it equal to positive root 3? And I use that reference angle. So the tangent of 60 degrees is positive root 3. So over here in the second quadrant, I know I'm going to have a reference angle of 60 degrees since that's where tangent is equal to root 3. So therefore, where is it equal to negative root 3? That's going to be, let's go over to this quadrant. And I know that, let's see, that's going to be 180 degrees is here. Subtract that 60 off, and that gives me a theta value of 120 degrees. But again, the problem is I want an answer between 180 and 360. Now, here's where the period comes into play. I know that that answer repeats every 180 degrees. And I can either add 180s or I can subtract 180s, but that answer is going to repeat every 180. So that 120, if you add 180 to it, you get 300. That's another place where the tan is equal to negative root 3. You can add 180 again and again and again, or you can subtract it. However, this is going to be the only place between 180 and 360 where I have a tangent that's equal to negative root 3. Okay, number 4. Okay, you got cosines on both sides, but they can be combined. So I'm going to move these cosines over here. A positive is going to turn into, again, these are terms, just like if they were 2s, 3s, 4x's, they're terms. So when you move that positive 3 cosine over to the left, it becomes negative 3 cosines, just like 5x minus 3x gives you 2 cosine theta. Now, in the same step, let me come down here. In the same step, I'm going to go ahead and move this root 2 to the other side, and it will become negative root 2. Next step, since 2 is being multiplied by cosine, I'm going to move it over by dividing. And I now have where is cosine equal to negative root 2 over 2. Let's find all the answers. Since it's cosine, let's find all the answers from 0 to 360, and then we'll use that to find where we're looking for. So cosine is negative. All students take calculus. Cosine is positive here and here, so my answers, where is it negative, is going to be in the second or third quadrant. Let's go ahead and ask ourselves, okay, where in the first quadrant, what's my reference angle? Where is cosine equal to positive root 2 over 2? And that's going to be a 45-degree angle, and that tells me what my other two reference angles are going to be. So therefore, this angle is going to be 180 minus the 45, which gives me theta is equal to 135 degrees. And my second answer will be that same 180, but I'm going to tack on an additional 45, and that will be 225 degrees. And again, those answers will repeat every 360 degrees. So I could add 360 here. I could subtract 360. I could do the same thing here, and it gives me additional answers. But I'm only looking for the answers between 0 and 270. Both of those answers are between 0 and 270. And if you add 360s, then they're going to be too big. So that's going to be my only two answers. Okay, on number 5 and 6, notice we're dealing with radians now. We're going to do the same thing. I actually treat it the same, and I usually just find my answer in degrees, and I transfer them back to radians just to make them a little bit easier. So minus sign, I'm going to move over here to the other side by doing plus sign. Sine plus sine, you now have 2 sines. So 2 sine of theta is equal to 2. Next step, I'm going to divide by 2, and I now have the sine of theta equals 1. So sine is positive, and you can go through that if you'd like to, but this is a quadrantal angle. Where is sine equal to 1? Sine, again, is a y value. On my unit circle, the only place that it's going to be equal to 1 is right here at 90 degrees. So my answer is going to be the only one between 0 and 360 is going to be 90 degrees. And that's what I want, all the answers from 0 to 360. And since they do want radians, I know that pi is 180, so 90 would be half of that, or pi over 2. Number 6, let's move our tangent over by subtracting. I now have 2 tangents. When I subtract it off is equal to 2. Move the 2 over by dividing, and that gives me the tangent of theta is equal to 1. And again, I'm looking for all answers. Since it's tangent, I'm going to start out with all my answers from 0 to 180 because that's the period of it. Tangent is positive in the first quadrant. And what the tangent of what angle is equal to 1? Well, that's going to be a 45-degree angle. So theta is going to be 45 degrees. However, that 45 degrees does not fall between, this is 90 and 270. That's the answers I'm looking for, is anything from 90 degrees up to 270 degrees. So again, what I do is I use the period. I tack on extra 180s until I get all the answers that I'm looking for. Tack on one 180, and that's 225 degrees. If you tack on another 180, that's 405 degrees, which is actually already out of that range, so we don't want that answer. So my only answer is going to be 225 degrees. Okay, the next set of equations are actually going to involve factoring. And notice that I've got squares here. It's kind of like having x squareds. And we know that when we're dealing with parabolas or quadratic equations, a lot of times we're going to have to factor. So as we work through these, now notice they do ask for the answers between 0 and 360. I just want to point that out. And it says give the answers in degrees. As we work through these, I want you to think, hey, these problems are just like this one. It's just like x squared plus x equals 0. We're going to treat it just like a quadratic equation. If we have common factors, in this case an x, we're going to simply factor those factors out. X times x plus 1 is equal to 0. And then we use the zero product property and set it equal to 0 and do all of that. So let's go ahead and do that on this one. I notice that we already have equals 0, so I'm just going to see, do I have any common factors? And both of these values have a sine of theta. And I ask myself, sine of theta times what gives me sine squared? And that would be sine times sine. Then I say sine times what gives me a positive sine? And that'd be plus 1. So same way that it was x times x plus 1, it's now sine times sine plus 1. Once you break it apart with factoring, two things multiply to give you 0. One of those two things must be 0. So we then split it up and say, well, I know that either the sine of theta is 0 or the sine of theta plus 1 is equal to 0. Let's go ahead and move that plus 1 over, and that gives me the sine of theta equals negative 1. And you can kind of see where we're going with this. You're going to have two sets of answers. So all the answers from 0 to 360 where sine is equal to 0. So you can sketch it out if you'd like to. Zeros and ones for sines and cosines, that's your quadrantal angles. And sine is equal to 0 here and here. So your two answers for where does sine equal 0 would be at 0 degrees or 180 degrees. So there's two of your answers. The next one, where does sine equal to negative 1? Again, that's one of our quadrantal angles. Sine is equal to positive 1 here, 0, 0, and negative 1 here. So my other answer is going to be 270 degrees. So, and just quick reminder again that you can also, since it's sine, you could also add rotations. And that is important because I just noticed something. We're looking for all answers from 0 to 360, including 360. So if you were to add 360 to this, that actually gives you another answer at 360 degrees that would be included in that range. So there's all my answers. Now I do want to go one step further with this, and here's what I've done. I've actually graphed it. Here's the graph of sine squared plus sine, and we're wanting to know where does that equal 0. And if you would like to, you could graph 0 with it as well. Let's see if I can get it to pull up here. You could say, I want to know, let's see, y. Well, let's jump back up there. Down here, it's not cooperating. Y equals, there we go. So there's my two graphs. I want to know where the two graphs are the same. And I see that the graphs cross here, the graphs cross here, the graphs cross here, and the graphs cross here. And you can see it kind of starts over there. Again, even though it's not sine, cosine, just plain and basic, you still have a periodic function and you're going to have repeating answers. So this 0 answer repeats actually over here at 360, repeats again over here at 720. This little in-between answer right here at 270 is going to repeat 360 degrees down the road again here because of that same periodic nature. Those answers are going to repeat over and over and over. Okay, next problem. And we'll try to graph it too after we finish just to see what this one looks like. So you have the cosine times tangent plus cosine. Now notice you've got two terms. Both of those terms have a cosine, so let's go ahead and factor that out so that we can separate them. We don't want cosines mixed with our tangent. So we have cosine times the tangent of theta plus 1 is equal to 0. So now notice we have our cosines here, our tangents here. They're not dealing with each other. They're now being multiplied, and I can now split them by saying if two things multiply to give me 0, then either cosine of 0 or the tangent of theta plus 1 is equal to 0. And I'm going to go ahead and save myself a step by moving that plus 1 over, and I'm just going to erase that and put tangent of theta equals negative 1. So we've got two different questions here. Where is cosine equal to 0? And again, that's a quadrantal angle. Cosine is an x value on your unit circle, and x is equal to 0 here and here. So my two answers there would be 90 degrees and 270 degrees. And if we add 360 to those, we're not in that 0 to 360 range, so we don't have any extra answers there. And then we ask ourselves, where is tangent equal to negative 1? Now, first off, tangent's period is 0 to 180. So I'm only going to look for the first and second quadrant answers. And I know that tangent is negative in the second quadrant. First step, forget about the negative. Ask yourself, where is tangent 1? And that's going to give you a reference angle, and that's 45 degrees. So this reference angle right here will be 45. Let's try to write that a little bit better. And since that's 45, the actual angle right here, well, I know this is 180. When I subtract that 45 off, I get an angle of 135 degrees. Since it is tangent, that answer will repeat again in 180 more degrees. So you ask yourself, will it still fall in this range between 0 and 360? Because that's the only answers I'm looking for, and it will. If you add 180 to it, that gives you, let me just put a comma between, that gives you an answer of 315 degrees. So those, the answer to that equation is going to be those four angles, 90, 270, 135, and 315. Now let's look at that on a graph. Okay, here's our graph, and oddly enough, it kind of looks somewhat like a sine or cosine curve, and we're simply asking between 0 and 360, which would be between here and here, where is it equal to 0? Where does it cross pretty much your 0? Y equals 0 is the x-axis, and there's the only places where my graph crosses the x-axis. And you might be thinking to yourself, that's odd because I thought we had four answers. Now, let me go back and remind you of something I actually said when we started this. There is a possibility for extraneous answers. And I just want to remind you what extraneous is. Extraneous is an answer that looks right, but once you plug it in, something's fishy about it. Now, let's go back to the original problem. And let's say what happens when I take these thetas up here and I plug in these 90s, 270s, 135s, and 315s. These were the two answers that didn't work. And I want to remind you that when you plug in 90 and 270 right here, the tangent of 90 and the tangent of 270 are actually undefined. You can't do the tan of 90 or the tan of 270. So when you go back and plug it in, those two answers do not work. So you actually only have two answers, which is what you saw on the graph. Number 9. Sine squared plus 3 sine minus 4. Now let me show you a trick right here. Some people like to do this. This is a quadratic trinomial that involves sines, and a lot of people don't like to deal with sines mixed with that. So what you can do, if you would like to take that sine out and change it with maybe the letter U or a different letter, you can do that. You've got u squared plus 3u minus 4. And that way you don't have to think about sines mixed with quadratics and then try to factor that. Let's remind you how to factor this. U times u gives you u squared. What adds to give me 3 multiplies to give me a negative 4 would be a positive 4 and a negative 1. So that means that u is equal to negative 4 and u is equal to 1. Now then go back and think, now wait a minute, what was u? We took out the sine and replaced it with u. So now that we're down here, now let's take the u back out and replace it with the sine of theta. So the sine of theta equals negative 4, and the sine of theta is equal to 1. And then you can solve it from there. Now, if you would like to, you can do it the other way and have your two parentheses and say, okay, sine squared would be a sine theta times the sine of theta. What adds to give me 3 multiplies to give me -4, and do it the exact same way. +4, -1, set each equal, and you can do it that way as well. So first one, sine of theta is equal to -4. There is absolutely no way that you can find the sine of an angle that gives you -4. Reminder of what the sine graph looks like. The sine graph has a range from -1 to +1. You will never get above +1. Sine will never go below -1. So therefore, what gives you a sine of -4 is non-existent. Now, what gives you a sine of 1 is a quadrantal angle once again. The only angle that gives you a sine or a y value of 1 on the unit circle would be a 90-degree angle. So that's going to be your only answer from 0 to 360. Okay, here's the graph of that equation. And again, we're only looking for the answers from 0 to 360, and it goes up and touches it. It doesn't even cross it there. It just touches it there at 90 degrees. That's the only place. Now, you do see those answers again repeat every 360 degrees, but between 0 and 360, 90 is your only solution. Number 10. Says cosine squared minus 2 cosine minus 3. So again, you can use the U trick again, or if you're comfortable with the cosines, we'll do it with the cosines this time. You can do it either way. So 2 sets of parentheses, and we'll make these parentheses a little wide so I can fit this in here. So I know the cosine of theta times the cosine of theta gives me cosine squared. What adds to give me -2 multiplies to give me -3 would be a -3 and a +1. We set each equal to 0. The cosine of theta minus 3 equals 0, and the cosine of theta plus 1 is equal to 0. If you'd like to save yourself a step and move the -3 over by doing +3, move the +1 over by doing -1, you could do that. For the exact same reason, this is not going to, as the last one, this is not going to have a solution. Cosine has a range from -1 to +1. 3 is way too high. And then you ask yourself the cosine of what is equal to -1. That's a quadrantal angle because it's zeros or ones. So cosine's an x value on the unit circle, or you could look at the unit circle here. The only x value that's equal to -1 is at 180 degrees. Let me go back. So therefore, your only answer to this equation is going to be 180 degrees. Now let's go ahead and look at the graph of that. And there you see that graph, and between 0 and 360, the only crossing point, and again, it doesn't cross again, it just skims it. The only touching point or crossing point is at 180, which is the only answer we got. Okay, number 11. Now these, we're getting a little bit more difficult. This is a special type of factoring, and if you would like to relate it to 4u squared minus 1 equals 0, that is a difference of squares. Difference of squares factor into conjugates. Again, you ask yourself what multiplies to give you 4u squared, and that'd be 2u times 2u, what times itself. And then to make it conjugates, it'll be a positive and a negative. What multiplies to give you 1 would be a 1. So this thing is going to factor into 2 cosine theta plus 1 and 2 cosine theta minus 1 is equal to 0. Since two things multiply to give you 0, we're going to set each of them equal to 0. You could go ahead and move the 1 over. It's going to turn into a -1, and then we're going to divide by 2. And that's going to give me, the first one would be the cosine of theta is equal to a -1/2. When you move the 1 over, it becomes a +1 here and divide by 2. That would give me the cosine of theta equal a +1/2. So that's going to be pretty easy because we're actually dealing with the same value. So whether it be positive or negative, it's going to be the exact same reference angle. So let's just all do it on one graph instead of having to do one for each equation. So where is cosine equal to a positive value? That would be, there's going to be an answer here. There's going to be an answer here for this side of the equation. Whereas cosine equal to a negative will be an answer here and an answer here for this side. And then we ask ourselves, okay, what is our reference angle? Cosine is a half at 60 degrees. So that's actually going to be one of my answers for over here. This is also going to be a 60-degree angle. So this is 360. Take away that 60. That would give me a 300-degree angle. So there's my two answers for that side of the equation. This is a 60-degree angle. I know this is 180, so 160 degrees short of 180 would be a 120-degree angle. And then 60 degrees beyond 180 would be a 240-degree angle. So there should be the four answers for this. Now, just a quick reminder so we don't forget that these answers, we could still tack on 360s to every one of these to give us other answers, but they're only wanting us on these problems to give the answers between 0 and 360. And here is the graph of that function. It's a pretty plain and simple graph. Looks just like a sine curve. And we're looking for all answers from 0 to 360, where it's equal to, where's my graph equal to 0? We get 60, 120, 240, and 300 as our four answers. Okay, well, number 12. Notice that what's different is we've got a number out front. And I want to go ahead and remind you that this is what we call slip and slide or bottoms-up factoring. So if you would like to write this, it might be easier on this one. If you would like to write it in terms of u's instead of signs, let's do 2u squared plus 1u minus 1 is equal to 0. Just to remind you on how we do bottoms up or slip and slide factoring. Step number 1, which is where it gets its name, we're going to move that 2 to the end. We're going to slip it to the end, so we have now u squared plus u. We're going to multiply it by this 1, and I now have minus 2 is equal to 0. I break it down like normal. I ask myself what values add to give me 1 and multiply to give me a negative 2. There's a 1 here and a negative 2, and that would be a positive 2 and a negative 1. Now the number we move to the end, we're now going to divide each of these numbers by that factor, and it was a 2. If it divides, great. Like u plus 2 divided by 2 is 1. If it does not divide, like the second one, it'll give us a decimal, where we're going to reduce, if possible. And if it does not reduce, we're simply moving it back up. We're sliding it back to the front. And that would be 2u minus 1. And I'm going to go ahead and solve these. So my u values would be negative 1. Or if I move the 1 over and divide by 2, my second u value is a half. Now go back and ask yourself, now what was u again? U was sine. So therefore, my two equations are the sine of theta is negative 1, and the sine, not u, the sine of theta is equal to a half, and then we're going to work it from there. Sine of theta is negative 1 is a quadrantal angle. Sine is a y value, and on my unit circle, my y value of negative 1 occurs at 270 degrees. There's my first answer. Where is sine a positive value? Now I have a first quadrant answer and I have a second quadrant answer that also has a sign that's positive. Sine is positive at a 30-degree angle. So there's my first answer, 30 degrees. My second answer has a reference of 30. This is 180, so 30 degrees short of 180 would be a 150. So there would be my other two answers. Let's go ahead and take a look at the graph. Okay, here's my graph, and it's a pretty interesting looking graph now, but again, we're looking for all the places where the value of this graph is equal to 0 or crosses the x-axis, and that occurs at 30, 150, and 270, and then not again until after 360. Okay, number 13 is a very similar problem. I'm going to go ahead and write it with u's. That'd be 2 cosine squared minus 5 times the cosine, which we'll just replace with u. I'm going to go ahead and move my 3 over by turning it into minus 3. Again, we do have a bottoms-up factoring problem. Move the 2 to the end. That turns it into u squared minus 5u minus 6 is 0. Two sets of parentheses. Put your u's first. Adds to give me negative 5, multiplies to give me negative 6 would be a negative 6 and a positive 1. Ask yourself what you moved. It was a 2, and let's go ahead and divide by the 2. That would give me a u minus 3 is equal to 0. And the second one, I'm just skipping a step here. That'd be a 2u plus 1. And I'm going to go ahead and set it equal to 0 as well. When you solve each of these, you get u equals 3 and u equals negative 1/2. Subtract 1 divided by 2. Again, my u value is a cosine, so let's replace it again. The cosine of theta is equal to 3. The cosine of theta is equal to negative 1/2. Okay, once again, cosine can never have a value bigger than 1 or smaller than negative 1. Cosine is equal to a negative 1/2, okay? Our reference angle there, well, where is cosine equal to 1/2 would be a 60-degree angle. But our answer is a negative 1/2, so we're going to be in the second or the third quadrant. This is my 60-degree reference. This is 180. 180 minus 60 gives me a value of 120 degrees. 180 plus the 60 would give me a value of 240 degrees, and that will be my two answers. And I'm not going to graph these for the rest out. You can graph them if you'd like to double check them. Next problem, again, I'm going to replace my signs with u, so this would be 3u squared. Let's go ahead and move these values over. That'd be minus 2 sine and minus 1 as you move them over. Bottoms up factoring, u squared minus 2u minus 3 is equal to 0. Two sets of parentheses. U times u gives you your u squared. Adds to give you negative 2, multiplies to give you negative 3. It would be a negative 3 and a positive 1. Ask yourself what you moved, and it was a 3, so let's divide both of these values by 3. And you get u minus 1, and move the 3 back up. That'll be a 3u plus 1. Now this one's going to be a little different. So set them each equal to 0, and you're going to get u is equal to 1. I'm going to come over here and write it, or u is equal to negative 1 divided by 3. So now let's replace it back with the sign. So I'm looking for where is sine of theta equal to 1, and where is my sine of theta equal to 1/3. First part is easy. Again, this is a quadrantal angle. We've solved it numerous times, so I'm just going to go ahead and tell you my first answer is 90 degrees. However, my second answer, if you can look at your unit circle, where is sine equal to 1/3? And again, sine values are your y values. And you remember all those y values, there's absolutely nowhere it's equal to 1/3. Now we have a half, but my y value of 1/3 would be somewhere down here because 1/3 is smaller than a half. It'd be bigger than 0, but smaller than a half. So we're looking at an angle somewhere around 20 degrees or something like that. So let's talk about what if you have and that should actually be a negative 1/3. The reference angle will be less than 30. So what if you have an angle that you're not used to? How do you find it? Okay, step number 1, let's find our reference angle. And to find your reference angle, you always ignore that negative value. We're going to move sine over by doing the inverse sine, as we did in previous lessons, the inverse sine of 1/3. And that's going to give us our reference angle. And when I type that in, I get a reference angle of 19.5 degrees. That's the reference angle. Now, just a reminder, we're talking about a negative 1/3, so let's draw this. Sine is negative in the third quadrant and in the fourth quadrant. My reference angle is this angle. So now it's pretty easy. So what is this angle here? Okay, I'm going to do my 180, and I'm going to add on my reference angle. 180 plus 19.5 will be 199.5 degrees is my first answer. My second answer, this is 360. We're 19.5 degrees short of that, so we're going to subtract off 19.5, and that's going to give me 340.5 degrees. That would be my other two angles. So my three places that solve this equation, and again, these answers will repeat every 360 degrees because we're dealing with sine equations. My three answers are 90, 199.5, and 340.5. Okay, our last set of problems actually involves using identities to solve, and they've listed the common identities that we're going to use: Pythagorean, reciprocal, and double angle. Those are the most common that we use in these problems. Now, I do want to give you a word of advice about what do you do to solve something that looks that terrible. Here's the rule. Try to do one of two things. Either try to get rid of cosines if you have a sine problem, or sines if you have a cosine. Get just one or the other. Let's not have cosines and sines. Let's have just all sines or just all cosines. Now, if you do have still two different trig functions, try to separate them by factoring. And we've done that previously. If you have a cosine that you can factor out and break it into two separate equations by using the zero product property like we did before, let's do that. But on this problem, I noticed something that just sticks out like a sore thumb, and that's that cosine of 2 theta. which we know we have an identity that we can replace that with. I know that the cosine of 2 theta is equal to cosine squared theta minus sine squared theta. Now, you might already see the reason that I picked that identity to use, because that's going to cancel with my sine squares there, and it gives me a much cleaner, simpler equation to work with. So now I have 4 cosine squared theta is equal to 3, which looks much better. So we cleaned it up, and again, you're starting to hopefully see the purpose of having identities. And now let's solve it from there. So we have now cosine squared is equal to 3/4. To get rid of a square, now this goes back to quadratics. To get rid of a square, we don't square root, we plus and minus the square root. So we're going to do plus and minus the square root of 3/4. Anytime you have the square root of a fraction, that fraction can be split. I'm just going to do it right here next to it. That's going to be plus and minus the square root of 3 over the square root of 4. Square root of 4 is 2. So notice what you've got now. The cosine of theta is equal to plus and minus root 3 over 2. And hopefully you recognize root 3 over 2 is like, hey, that's a common angle. I can do that. So notice also we have the plus and minus. So we're actually talking about which quadrant's plus and minus, and that's every quadrant. It's cosine is positive in this quadrant and this quadrant. And then we've got to throw in our negative answers as well, which will be negative in this quadrant and this quadrant. Our reference angle, where is cosine equal to root 3 over 2? That's going to be a 30-degree reference angle. And that's going to be actually one of my first answers. And if you need to split this, if you'd like to say, okay, cosine of theta equals root 3 over 2 and cosine of theta equals negative root 3 over 2, you can split it if you'd like to. Well, 30 degrees is your first answer for this one. Where else is cosine equal to a positive? That'd be down here in the fourth quadrant. This is 360. My reference angle was 30. So 30 degrees short of 360 would be 330. My cosine is negative in the second quadrant. So therefore, since this is 180, this would be 30 degrees short of that, which is 150. My last answer, it's also negative in this quadrant. This is 30 degrees. So 30 degrees in addition to this 180 would be 210. So there's the 4 places that actually solve that equation. Now let's make sure that we answered what they said. They want the answers from 0 to 180. So since they only wanted the answers from 0 to 180, we can throw these 2 out, and 30 and 150 will be the only 2 answers. Okay, the next one, again, sticking out to me is the sine of 2 theta, which is one of your double angle identities. We know that there's only one that goes with the sine of 2 theta, and that's 2 times cosine theta, sine theta, and I think I did those out of order, but it doesn't really matter. 2 sine theta cosine theta. Then you still have minus the cosine of theta equals 0. Now, some of you might be thinking, I thought you said that you don't want sines and cosines, and you don't, unless you can do this. Notice you have 2 terms. They both have a cosine. And what I'm now going to do is I'm going to factor that cosine out. I'm going to be left with 2 sine theta minus 1 equals 0. So now I factored it, and I can break it apart since I've got multiplication, and I can say either the cosine of theta is 0 or 2 sine of theta minus 1 is 0. So now notice that this only involves cosines, this only involves sines. So first part of the problem, where is cosine equal to 0? That's going to be a quadrantal angle here or here. So that's going to be either at 90 degrees or at 270 degrees. Second part, let's move the 1 and 2 over. That's going to be the sine of theta equals a positive 1 over 2. And you ask yourself, where is sine positive first? You're going to have an answer here, and you're going to have an answer here. That's where sine is positive. Reference angle, what the sine of what value is a half would be a 30-degree angle. So that means this must be a 30-degree angle, and this value is 30 degrees. Since this is 180, 30 degrees short of 180 would be 150 degrees, and there is going to be your 4 answers. But again, I just remembered they only wanted answers between 0 and 180, so we will throw that 270 out. And number 17, I noticed on number 17 we actually have 3 different trig functions. We have cosine, sines, and tangents. However, I do know that I can switch, anytime I have tangents, I can switch that to sine over cosine. So I have now the cosine times sine over cosine, and that's actually going to get rid of a couple of my different identities. And then that's minus, or excuse me, a couple of my functions by canceling that out. So I now have the sine of theta minus sine squared theta is equal to 0. Now I have all sine stuff. Now I do want to talk a little bit about this tangent stuff, and we saw it on an earlier problem. Make sure that you remember that anytime you're dealing with tangents, you have some undefined values sometimes. So let's be real leery about some of our answers here. So I'm going to factor that sine out. So I've got the sine of theta times, because both of these terms have sines, that'll be 1 minus the sine of theta, when I factor it out, is equal to 0. Split it, and you now have the sine of theta is equal to 0, or 1 minus the sine of theta is equal to 0. Set each of these terms or factors equal to 0. The first one is easy. We ask ourselves, where is sine equal to 0? That's a quadrantal angle. That's going to be at 0 degrees or at 180 degrees. That's where my y values are 0. Now the second one, instead of moving the 1 over, I'm going to move this minus sine over, and that gives me 1 equals the sine of theta. So that way I only have to move one thing. So then again, we have quadrantal angles. We ask ourselves, where is the sine of theta equal to 1? And that's at 90 degrees. But again, remember what I said. Let's be leery of that tangent value. If you go back and say, okay, if I plug these three values into my original, does it work out? Do I get 0? Well, you can't plug 90 degrees in. The tangent of 90 degrees is undefined. That value is not pluggable, if that's a word. You can't plug it back in. So the only two answers are going to be at 0 and 180. Now, I do want to go and show you the graph and demonstrate how you know from looking at a graph that ain't going to work. Okay, so here's the graph, and you might be saying to yourself, oh, look, right there at 90 degrees, it does work. Now, let me tell you, Desmos does the craziest thing here. There should not be, but there's my 0 degrees, and there's my 180 that works. It looks like, according to this graph, that 90 does work. However, 90 cannot be plugged back in because, once again, you cannot find the tangent of 90 degrees. It's an undefined value, so therefore we're going to strike that 90. It's not going to be a valid answer. Okay, number 18, cosine squared minus cosine plus 1 equals sine squared. Now, notice again we have a mixture of cosine stuff and sine stuff, and we can't have that. Now, the best place to look when we're trying to convert sines to cosines, or especially sine squares to cosine squares, is Pythagorean identities. I know that sine squared plus cosine squared is equal to 1. So therefore, what can I do with sine squared? Well, if I move that cosine squared over, I know that sine squared is equal to 1 minus cosine squared. So I can replace it with that, and now all of a sudden, no more sine stuff. So let me go ahead and bring everything else down. The cosine squared theta minus the cosine of theta plus 1 is equal to that. My 1's, as I move them, will actually cancel each other out. My cosine squared, as I move it to the left side, I now have 2 of them because it changes to a plus. So 2 cosine squared minus the cosine is equal to nothing. We've moved everything from this side, so 0's left. I can now factor. Both of these terms have a cosine, so let's factor that cosine out. So you're going to be left with 2 cosines here minus cosine times 1 would give you the cosine. Set each of these values equal to 0, so you now have the cosine of theta is 0, and 2 cosine of theta minus 1 is equal to 0. Cosine equal to 0, let me scroll back up, is a quadrantal angle. Cosine is an x value, and that x value is equal to 0 at both of these, so that's going to give me my first two answers of 90 degrees and 270, which we can already strike because they only want the answers from 0 to 180. The second one, let's move the 1 and 2 over. It gives me the cosine of theta as a half. Cosine is a positive value in the first and fourth quadrant because, again, all students take calculus. My reference angle that I'm looking for is going to be cosine of 60 degrees is equal to a half. And since where one of our answers in the first quadrant. That's going to be my first answer. This reference angle is also 60, and it is this angle is going to be 360 minus 60 because it's 60 degrees short of 360. So that's going to give me a 300-degree answer. And again, since I'm only looking for answers between 0 and 180, we'll strike that one as well. So my two answers there should be 60 degrees and 90 degrees. Okay, number 19 says the cosine of 2 theta, double angle, plus the cosine of theta is equal to 0. Now let's go back. I've actually got my I've got my different trig identities pulled up here. And here are my double angle identities right here. And just a reminder that cosine actually has 3 of them. Now, I want to point out that if I use cosine squared minus sine squared in this problem, cosine squared minus sine squared plus cosine is equal to 0. You could try to factor it, but there's still going to be a mixture. So why not, since we're trying to deal, if possible, all entirely with cosines or all entirely with sines, since I have a cosine here, let's try to stay away from anything that involves sines. So let's go back to our reference page here, and let's use this one. The cosine of 2 theta is equal to 2 cosine squared minus 1. So let's try that one. 2 cosine squared minus 1 plus the cosine is equal to 0. And what you've actually got there is just a basic quadratic trinomial. Now, these are out of order, so you might want to rewrite it. And as I rewrite it, I'm going to go ahead and replace it with my u's. So it'd be 2u squared plus u minus 1 is equal to 0. And then you just have a slip and slide or a bottoms up problem. Move the 2 to the end. That's going to be u squared plus u minus 2 is 0. 2 sets of parentheses. It's going to be u and u. As to give you 1 multiplies to give you negative 2. It would be a positive 2 and a negative 1. The number that you moved is now divided by. You now have u plus 1. And that will not divide or reduce. So let's move the 2 back up to the front, and that'd be 2u minus 1. Once you set each of these equal to 0, you get u is negative 1 and u is 1/2. Now go back, our u value actually replaced cosine. So you now have the cosine of theta. Scroll back up. The cosine of theta is negative 1. The cosine of theta is 1/2. And that was a bad looking theta. Let's try that one more time. The first one's quadrantal. The cosine is equal to negative 1. That's, again, an x value. The cosine of 180 degrees is negative 1. Cosine is positive 1/2. Cosine is positive in these two quadrants. My reference angle is going to be a 60-degree angle, which will be my first answer. This angle right here will then be 60 degrees short of 360, which will be 300, which is my second answer. Since they're only looking for answers between 0 and 180, that would mean 60 and 180 are my two answers. Okay, finally, number 20, the last one. Now, for the same reason that I told you on the last one, we have all sine stuff on this problem except for this. And I know that I do have a double angle identity that involves only sine stuff. So we go back, and my cosine of 2 theta right here is equal to 1 minus 2 sine squared. So let's replace it with that. 1 minus 2 sine squared theta plus 8 sine squared theta plus 11 sines, seems like a long problem, plus 3 is equal to 0. Now let's clean this thing up by combining some like terms. These two will combine into a 6 sine squared theta plus my 11 don't combine with anything, but my positive 1 and positive 3 gives me a positive 4. So there's where we're at now. Again, I do like replacing, if this is factorable, I like replacing that sign with a u. Now, if this was not factorable, it would be ugly because you would have to use the quadratic formula, and that would just not be a pleasant problem to work. So there's what we have now. Let's try to factor it, slip and slide. Move the 6 to the end. I shouldn't have done that yet, but we can actually just do it right here. Let's do u squared plus 11u plus 24 is what we're trying to factor. So that'd be a u, and a u adds, multiplies will be a positive 3 and a positive 8. Now the 6 is what we move, so let's divide both of these by 6. And I now have u plus a half and u plus 4/3. You must reduce. That will end up factoring into a 2u plus 1 and a 3u plus 4. It's equal to 0. So my two values for u is going to be a negative 1/2 and a negative 4/3. Now my u value replaced sine, so I'm going to go ahead, and that's the reason I didn't put the u there. I'm going to go ahead and replace that u back with sine of theta. Now the first one is a common one. The sine of 30 degrees is equal to a half. My reference angle here is going to be a 30-degree angle. That's supposed to be a colon. My reference angle is a 30. Sine is negative in the third and fourth quadrants. Reference angle is 30. This is 180. 30 more than 180 is 210 degrees. 330, 30 degrees less, or excuse me, 360, 30 degrees less than 360 is 330. There's your first two answers. Now my second answers, the sine is 4/3. That's not one of your common 1/2, root 2 over 2, root 3 over 2, 1. That's not one of the common ones. So what you're going to first have to do is find a reference angle. Ask yourself, the sine of what is equal to a positive 4/3? Okay, and the way that you would do that is to move sine over, you would do inverse sine. And as I type that into my calculator, I notice, and I wasn't thinking, I notice an error. The reason for that error is 4/3 is 1.3 repeating. And just a quick reminder that sine cannot be bigger than 1. It can be smaller than negative 1. This would have no solution. So where is sine equal to negative 4/3? Nowhere, because it can't be smaller than negative 1. So therefore, the only answer that you're going to have, because, well, we only wanted the answers between 0 and 180. And both of these answers are not between 0 and 180. So this thing between 0 and 180 has absolutely no answers. It does have solutions, just not in the range that they're asking for.